If you have a goal and if you want to execute it successfully, so you need to plan, right? Someone said, right? Think before you act. So better is your plan, better your execution, and you will reach your goal correctly. That's how. So this pattern focuses on planning. So if your use case involves very complex problem, then your go-to design pattern is the planning design pattern, where you are giving your agent instruction that you need to plan first and come up with a concrete plan, execution plan, then you act on it. So that's how this pattern is useful if you are dealing with a very complex workflow. So let's see. So in this video, basically that's what we will talk about. What is this design pattern? What are the underlying architecture behind it? And the core idea, again, when you should use, when not to use, the limitation, the trades-off, and also we will see what kind of bioinformatics use cases or life science use cases where this kind of design we can build. And again, we will do a hands-on where I will show you practically how you can build this kind of design patterns. So without any delay, let's start. So in this planning design pattern, so how the agent will first receive, let's say, a complex task. So it will first understand the requirement. That means it will go through the analysis phase, and after understanding the requirement, it will decompose or break the task into various subtasks, and then it will sequence them, like first 2, 3, 4, like that. It will order them based on their dependency, and then it will create an execution plan, and after that it will execute like 1, 2, 3, 4, and it will complete the result. That's what it will first analyze, then execute later. The core philosophy of this is like, instead of solving the task directly, jumping into the task, let's do it. Don't do that. Instead, agent will first create a structured roadmap before doing any work. So this is how that agent is trained, or we are telling the agent to do that. First plan, then execute. Okay. So what is this design? Again, the same thing. It decomposes a complex goal into smaller ordered subtasks. Then identify dependency, then it creates an execution plan, executes task only after the planning is complete. So planning complete, then execution starts. That's why the planning separates thinking from doing. So better the planning, better accurate would be the output. So you can say. So why the planning matters? Because planning surfaces complexity early. Okay, so if there are some challenges are there, it will, because better you plan, better you understand the problem, and so that you will not see surprises at a later stage, right? So that's what planning matters. And when should you use this kind of pattern? That's what I already said, like, when your task involves significant complexity, or maybe there are, multiple steps are there and the multiple dependencies is there, so then you have to plan it, right? How the dependency you will resolve. So that's where, planning is important. And that's what, similar example, coordination across system. Let's say you have system 1, system 2, system 3, you have a API call, you have a storage layer, you have, those kind of things. So then if a complex system, how will you orchestrate? So you have to plan, right? So that's where these planning agents are better suitable, to execute this kind of task. Typical example is like, multi-system integration requiring strict sequencing. Research workflows synthesizing diverse sources, same thing. Product development, like you have to design, then you implement, then test it. So it's a very complex system. That's where this kind of pattern. The main limitation is like, sometimes planning is overkill. Sometimes a very simple and well understood task you can, if you give this to this kind of system, they will, make it over complex. So that's why sometimes planning overhead are the main, side or limitations of this kind of system. Okay, so that's what you just need to know, like, the trade-off between, this agent and that. Some practical use case of bioinformatics, like for example, we are doing end-to-end variant interpretation pipeline. So now it's just not, given a variant, it will do, let's say given first queue file, you are doing this, then variant calling, variant interpretation, you have so many systems are there. It's a very complex pipeline, and how to interpret. For example, you are building an ACMG classification, right? So for example, so you have 28 different evidence codes, each codes require different databases to pull information and then logic and then doing that. So that kind of complex system may require a very sophisticated planning agent kind of system, right? Similarly, another example like multi-database annotation workflow, you have Nomad, CleanVar, multiple databases, how you will pull the information and identify the different information and compile the results. And some similar multi-stage omics pipeline in another example, like we have transcriptomics, proteomics, metabolomics. So how will you gather the information and integrate them and come up with the multi-omics analysis? So bioinformatics use case falls under that because we have so many complex, biological system is very complex, right? So that's where a good planning agent or agentic system will work very well in this, so that's why these workflows have dependencies that must be respected. The main core philosophy of using this kind of use case. Okay, so yeah, so let's do a use case here where I will show how this planning will work. It's a very simple demonstration purpose use case. So the planning design, right? So again, I will be using OpenAI SDK framework to build. And if this is first time you are watching, then go through my earlier videos series where I talk about how to build this system, but still I will explain how it works. So I'm importing basic libraries from agents, importing agent and runner. From .env I'm loading for environmental loading purpose, and where I have stored my OpenAI API key and I'm loading it. So it's loaded. So here I'm creating in planner agent. Okay. So and then an executor agent. So this is the planner agent is very important. So let's call this bioplanner, and here I'm giving a specific instruction. That this instruction plays a very important role because this is how you are defining that how that agent will plan. So here I have said that given a bioinformatics task, break it down into step-by-step plan, 3-step maximum. See, it will, if you don't restrict to 3, it will just give 10 step, 12 step. So it will consume more token, you will pay more. So just for demo purpose, I'm telling that given a bioinformatics task, just break down into 3 steps, 3-step maximum. Be specific and concise, only output the plan. Okay, this is how my planner agent I have defined. So now the executor agent will actually execute. So this is a very dummy example. So here I have said that given steps from this plan, just explain how you would execute it and what is the expected result in just 15 words or less. So this is the task I'm giving. But in a real situation, you will be equipping this agent particularly with some tools so that based on the task identified here, let's say it will run something step by step, it will do it. But for now, we are not. This agent will just simply print what he will do. Okay, just a simulation purpose. Okay, so for this we are again using the same same agent, but again for planner you can use some reasoning agent, very complex agent you can use here, so that agent is very strong. Not agent, my bad, the model I'm saying. Let's say GPT OSS model or GPT-5, very high power model, they can think, so you can use that. But for execution, you do not need we do not need brain, because you already know the plan, you have to simply execute it. So you can use a very simple, cheaper model. So that's why this is also very important concept that you need to learn, that don't always use bigger model for bigger problem. Now give the complex problem to a complex model, and smaller tasks you assign it to very small agents as well. So I can use GPT-5 for this, for planning, and very small GPT 4.1 nano kind of simple model to execute as well. Okay, so let's create for now both of them. And this is what I'm defining a workflow. Again, simple Python function. Here we'll ask a task from the user, and it will run in async mode. So step 1, it will give you the plan, generate a plan. So we are calling this planner agent and giving the task, and it will run it, and it will think, it will plan, and finally it will give you the result. So that's what here we will printing the output, and we are storing it in this variable. So now it will give the output in 1 dot, 2 dot, 3 dot, like that. That's what we are looping. I'm just doing some splitting the plan into each line, because each line will be one plan, splitting them and stripping them, and also if it is digit, then only take that line. So these steps will now contain the step 1, step 2, step 3, step 4, like that. So basically here we are looping over, and for every step I'm basically executing it. So this will be more like your real execution, like tool 1, tool 2, that way you can do it. But for now I'm calling the executor agent, and I'm giving him the task he has to execute. So now it will execute, and finally we are just printing what the output it got. Okay, so I'm defining my workflow, and now let's execute this. So I'm running this with this trace, and we are giving a task: analyze a DNA sequence for mutation and annotate their clinical significance. This is the task. So you see, this is a very complex problem because it's not a straightforward task. I'm saying that I will give you a DNA sequence. You have to analyze for mutation and annotate their clinical significance. So let's say what it comes up with. Okay, so let it run here. So now this will send the task to the OpenAI agent. So let's go there. Okay, it already did the plan. So it generated plan that it's saying that given a DNA sequence, first step is like align the DNA sequence against a reference genome to identify the variants or mutation using tools like BLAST or BWA. Now after that, annotate the identified mutation with database such ClinVar or Cosmic to determine their outcome. Then summarize the interpret the impact of this mutation. Okay, so now this plan is generated. Now it will execute one by one. Okay, so now it is doing the execution of first. Okay, so the first task was this one. It's a question, and actually ideally in real example it will execute it, but here execution is just simple print statement what I have defined, right? We have asked like, just explain how you will do it. So it's now saying that aligns the DNA to reference genome, identifying a variants or mutation with tools like this one. So now it will do the execution 2 and it will do the execution 3 as well. So let's see how the traces looks like. I'm going back to my OpenAI platform. So on the left hand side, I'm going to the logs and going to the traces over here, and this is my planning pipeline demo. So how is the flow? So the first it goes to the planner. So this is the system prompt we gave, and this is the input we gave. Now you see it came with the output, like 3-step process, step number 1, 2 and 3. So now it goes to the executor, bio executor, first step. So see, it went, the first question went and it generated an output. Now it goes to the second question, goes to this agent, second step. Now it generated an output. Now it goes to the third step. Again, third question goes to the, and it generates an output. So that's why the first step is planning. Now after that, task 1, task 2 and task 3. Okay, this is how it the agent is now executing, and we are executing because it's a step-by-step plan it gave. And if you come back here, so the plan was like this, and again it generated execute 1, 2, 3. So in summary, you load the library, you define 2 agents, and you can have multiple agent as well, task 1, task 2 and task 3, like that. But here we have one planner agent, one executor agent, and here we are creating running for loop the step by step. This is how you can define an planning. So in summary, use this planning agent kind of design pattern if you have very complex problem and the agent has to think and come up with the plan, and based on the plan you can leverage many other sub agents to execute each task as well. So that's all with this design pattern. Now the next one is a very important and interesting and most common design pattern, I would say, called the React design pattern, because here the agent will reason and it will act and it will also observe. Okay, I hope this video was useful. So I will see you in the next video. Thank you.